the topic. First, what we are going to discuss today is uses of dimensional equations. So yesterday we have seen dimensions, what is a dimension and dimension for different physical quantities, everything, and how to even some quantity, some physical quantity, it is unknown to you. If the equation, if the formula is given, and you know how to solve. Okay, formula is there means easily you can, with the by using the formula, you can very well give the dimension of the physical quantity, any quantity, and with the formula for that quantity is given means easily you can give the dimension of that particular physical quantity that we have seen. Right now, what are the uses of dimensional equations? See, there are very main uses. What are they? Number one, see, number one is, first one is conversion. We can conversion of, okay, one system of unit to another. One system of unit to another. That is very important. Okay, so we can convert once. There are different systems are there. We have seen MKS, CGS, FPS, SI system, of course. So therefore, you can convert from CGS to MKS, CGS to FPS, whatever is required. Okay, so easily by adapting this dimensional analysis. Okay, therefore, number two. Second one. What is the second one? Second one is you can check the correctness of the equation. Checking the correctness of the equation. See, what do you mean by that? If an equation is given, then whether the equation is correct or not. An equation means there will be left LHS and RHS. Okay, so the LHS dimension you have to see. LHS dimension should be equal to the RHS dimension, right? Only then the equation is correct. See, you cannot say that an equation is given 5 kilogram that is equal to 10 centimeter. Any sense in it? You have any sense in it?
No, ma'am.
No, ma'am.
You cannot
No,
equate kilogram with centimeter. You cannot equate mass with length. Length can be compared only, equated only with length. Okay, but like that, mass can be compared only with the mass. Therefore, you cannot compare mass with the time. Okay, because both the physical quantities completely separate physical quantities. So that is why now by using that, dimension of left side should be equal to the dimension of right side. Okay, well, therefore, what if this is the case, then you can say yes, the equation is dimensionally correct. We are going to check whether the equation is dimensionally correct. The numerical part we are not going to bother. See, we are going to check if one equation is given. Yeah, yes, it is correct. Why? Because length is equal to length. Velocity, that is equal to some velocity. Okay, density, that should be LHS. That should be equal to right hand side is density, means left hand side is also density only. So you can go ahead. Okay, so which means that the dimension is same. You are comparing only the same physical quantity. So that we are asked to check. Okay, so that is checking the correctness of the equation dimensionally. Dimensionally, that is very important. We are not going to see the numerical part of it. 3, if it is coming 3 V, that is equal to 2U. Okay, so 3, how you cannot say 3V is equal to 2U means 3 is equal to 2 how? So that we are not going to bother as long as the LHS, what is the dimension is equal to RHS dimension. That we are asked to check only that one. Dimensionally whether it is correct, the equation is correct, that's it, right? That only you can do only with by the method of dimension. We cannot bother about the numericals here, the numbers here, right? So that we will see while you are doing the problem. Third one. What is the third one? Third is very important, to derive a formula for a physical quantity. Deriving formula for physical quantities. How you can derive formula for physical quantities only when you know what are all the if it is a derived physical quantity, so you should know, you should have a data about what are all the physical quantities on which it depends. Fundamental physical quantities, or what are all the physical quantities on which this particular physical quantity for which we need to derive the formula depends. Once you know that, immediately you can apply dimensional analysis to derive the formula just like that. Very easily you can do, right? So these are all the three very important applications of dimensional equations. What is that? What are they? Conversion of one system of unit to another. Number two is checking the correctness of the equation. And third one is deriving the formula for the physical quantities. Everything by the method, by adapting, by applying the method of dimensions. Right. Hope you are following what are all the application. Now we are going to see one by one. First one we are going to see. What is that? Number one is conversion. Conversion of one system of unit. Okay, one system of units to another. Okay, how? Okay, very important, very important. Okay, so conversion. See, you know that already we have seen a physical quantity. Okay, the value, the size of the physical quantity won't vary if it is represented by different systems of unit. Size of the physical quantity. For example, okay, therefore, if I am finding length of the table, maybe it is 5 meter. 5 meter, it can be considered 500 centimeter. So because I am here, it is MKS system, and here it is RSI system, here it is CGS system. Okay, therefore, depending upon the system of unit, the number will also vary. Okay, but doesn't mean that the length of the table varies if I use MKS system, okay, other than CGS system. Not like that. Whatever is the system of unit you're following, okay, yeah, the given physical quantity dimension will be the same. It won't change with respect to the system of units what you are by which you are representing that physical quantity. Okay, therefore, like that, if I find a mass of a body, mass of a book, okay, mass of a book, let it be if it is 2 kilogram. 2 kilogram means it is 2 into 10 power 3 grams, therefore 2000 grams. 2000 grams. Therefore, now how am I representing here? You see, there are two. One is a number, another one is unit. Therefore, that is why already we have seen a physical quantity. Generally, I can represent a physical quantity Q as 1 with a number and 1. Okay, and the other one with a unit U1. N1, U1, and that can be represented by some other unit also, that is N2, U2. N2, U2. Is it clear? That is 5 meter here. You see, 5 meter is equal to 500 centimeter. Therefore, that is represented like that. L, that is equal to. So here the physical quantity can be represented by different systems of units. That is, one system is U1, system of unit, other system is U2, unit. Okay, therefore, the accordingly number will also, numerical value will also vary. That is why N1, U1 is equal to N2, U2. Right. Coming back to see, M, I am representing M by 2 kilogram. Okay, let me, this is a fundamental physical quantity now, length and mass. Let me represent something else. Okay, so velocity, some derived physical quantity. Okay, so velocity. So velocity, if I say a velocity is equal to m1, for example, 1 meter per second. 1 meter per second is nothing but 100 centimeter per second, right? So the velocity of the body is 1 meter per second, which means that it is 100 centimeter per second. Okay, therefore, now you can write this velocity as 1. It is independent of kilogram. Therefore, kilogram 0 power 0. kilogram power 0 means how many dimensions it depends. It depends on mass, length, and m, l, and t. 3 factors. Okay, in mechanics, we are bothering only about these 3. Okay, so I told you there are so many dimensions are there, 7 dimensions are there in physical world, but we are dealing with mechanics here. So only we are bothered about only 3. What are they? Mass, length, and time. So if I want to represent the velocity, how many dimensions, how many powers of dimensions, how many dimensions of length, how many dimensions of mass, how many dimensions of time? It depends. Therefore, if I want to represent 1 kilogram power 0, because it is independent of the mass, but it depends on the length, meter, m power 1, right? And what is second power minus 1? I think I can represent like this. It is the same, both are same only. I have represented like this. Okay, and that is nothing but 100. इसमें तो what is it? CGS system. Therefore, what is a unit for mass in CGS system is gram, right? Gram power 0. It is independent of gram because it is independent of mass. Gram power 0 and centimeter power 1 and second power minus 1. Is it clear? This is the complete representation. I have given the velocity, the value of velocity with respect to different systems of units. Okay, and how it depends on different dimensions, which kilogram power 0 means it independent of the mass, but depends only on the length with 1 dimension of length and minus 1 dimension of time. Okay, so this is how we have to represent. Hope you are following up to this. Is it clear, children? Is it clear?
Yes, ma'am.
Right.
Yes, ma'am.
Yes, ma'am.
As I told you, coming back to this. Here, let U1 here. What is U1 and U2 here? U1 here. Let me go for this. Okay, here U1 and U2 are the units. Correct? Or the units of are the units of different system of units. Okay. Are the unit of, check what is this? Yeah, for all the units of physical quantity okay, to or the two systems of unit. You can say U1 and U2 are, sorry, I can say U1 and U2 are the units of a physical quantity with respect to two different systems. Yeah, that is better because I have to give properly. See, U1 and U2 are the units of a physical quantity, single physical quantity. Physical quantity is the same of a physical quantity with respect to two different systems of unit. Okay. Okay, U1 and U2. That is what I meant here is kilogram, gram. Therefore, it is kilogram is which unit? MKS, and gram means CGS. Okay. Therefore, that is represented by U1 and U2. Right. Now, I want. Okay. Then what is that unit? So, unit U1 can be represented by let M1. M1, L1 and T1. M1, L1, T1 are the units, okay, of the quantity, physical quantity Q, okay, and M2, L2 and T2 are the units of the U, okay, with respect to two different systems unit. Okay, so what is that? M1, L1, T1 are the units of Q. What is that? Units of the physical quantity. What are the unit fundamentals? This is mass. It is a M1 is the, what is that? Mass. And L1 means it is a unit for length. T1, it is the unit for time with respect to one system of unit. Okay. And M2, what is M2? M2 is the mass, unit for mass. L2 is the unit for length. And T2 is the unit for time. Okay. With respect to, what is that? The other system of unit. Okay. Therefore, now,
Ma'am,
yeah, unit of,
ma'am, M1, L1 and T2 are the dimension of
no,
mass, length.
yeah, that is why. I am not, it is M, that is why. Yeah, good question. See, yeah, it is M, L, T are the dimension for mass, length, and time. You cannot go for M1, L1, this M1, L1, T1. I am taking that as a unit. Okay, so unit, okay, let me even, I can give even in a better way. It is only unit. I am taking that as a unit. M, capital M, capital L, capital T are the dimensions. Are you, I cannot have it. See, dimension of a given physical quantity is the same, which is irrespective of the system of unit. See, velocity. What is the dimension? What is the dimension of velocity? M power 0, L power 1, T power minus 1. Okay. You cannot say, listen, with respect to CGS system, this is the unit. This is the dimension. And with respect to MKS system, the other dimension, no. Dimension of velocity, irrespective of the system, it is M, L, what is it? M power 0, L power 1, T power minus 1 for velocity. Are you following, children? Is it clear?
Yes,
so you cannot even think about here M1, L1, T1. Hope you are following. But that is why, is it clear? Therefore, you cannot, whether whatever unit you are using, okay, it is the dimension of the physical quantity will be the same. So you cannot name it at M1, L1, T1, M2, L2, T2 and all. It depends on zero velocity, depends on 0 dimension of mass, 1 dimension of length and minus 1 dimension of time. That's it. Is it clear? So you need to represent 20. Therefore, that is why now I have taken, you should know this. Yes, you see, unit, see here M1, L1, T1, okay, or the, you can say even fundamental unit of, okay, let me give even in a better way. M1, L1, T1 or the fundamental units, okay, fundamental units of mass, length and time. And M2, L2, T2 are the fundamental units of what is that? Units of the same. Units of, okay, mass, length and time, okay, with respect to two different system of unit. I think now it is better. Okay, whether it is clear? It is, what is that for? Okay, let me have this one. M1, L1, T1 are the fundamental units of mass, length and time. And M2, L2, T2 are the fundamental units of mass, length and time with respect to two different systems of unit. What do you mean by that? Let me see. V is equal to this one now. 1 kilogram power 0, M power 1, S power minus 1. इसमें तो M1 is kilogram, L1 is meter and T1 is second. Okay. And what is M2, L2, T2? It is M2 is gram, L2 is centimeter. Are you following? And what is T2? T2 is second. T2 is second. Hope you're following. Is it?
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
Yeah, you cannot say M1, L1, T1. That is why I'm very emphasizing that it is nothing but now. It is not the dimension. It is the fundamental unit of mass, length, and time. Okay, with respect to one system of unit, M2, L2, T2 are the fundamental units of mass, length, and time. Okay, with respect to the system of units, let me say very important here, respectively. Okay, therefore, how can I represent here? N1 is a number. Listen, U1 is the unit. Therefore, I can represent here. The next question comes here. See, it depends on mass. But what is the dimension of mass? See, here is made to 0. Here, kilogram power 0, m power 1, and s power -1. That also matters, you know. The dimension only gives you what is that physical quantity, an idea about. Okay. Therefore, now I need to represent that powers also. Powers are very, very important. Here, the let. Now, A, B, and C. Okay. Are the respective dimensions of the quantity, physical quantity, okay, in mass, length, and time. What do you mean by that? This nothing but respective dimensions. What do you mean? The power is made of for with respect to the A is 0. Okay, and B is 1, C is -1. A, B, C, or the respective dimension is powers. Powers of mass, powers of length. Power of mass is A, power of length is B, and power of time is C. Like that. Therefore, this will not vary with respect to your system of unit. You see, इसमें kilogram power 0 means here gram power 0. Because it is MKC, it is MK system, it is CGS system. Whatever is the system you are following, it was 0 dimension of kilogram mass only. Therefore, kilogram power 0 means इसमें gram power 0, इसमें gram power 1 नहीं आएगा. Why? Because quantity is the physical quantity is the same. Therefore, here kilogram power 0 means gram power 0. Meter power 1. Length, it depends on one dimension of length. Okay. In MKE system, length unit is meter. Therefore, meter power 1. But in CGS system, what is a centimeter? Therefore, it should be centimeter power 1. That's it. You cannot say because it is some other system, it is centimeter power -1. No. Then it gives you, it will distort the physical quantity itself. The physical quantity will not be the same. So, therefore, here, if this is A, this is B, this is C, and here also that A, B, C has to be the same. Are you following? Irrespective of the system of unit, the power, the dimension of mass, length, and time should be the same, which is irrespective of the system of unit you are following. I think I'm making it clear. Is it clear?
Yes, ma'am.
Right? Okay.
Yes, ma'am.
Ma'am.
Yes, ma'am.
You should not say yes. You want me to once again explain? I'll explain. See, here U1. Therefore, I am going to represent what is U1. What is U1? Here, U1 should be represented by, it is a first one system of unit. What is the unit for mass? M1. Unit for length is L1. For time, it is T1. Therefore, I can represent U1 as M1 power A, L1 power B, T1 power C. Is it clear? So this gives you the complete unit like what is that velocity? What is the unit here? Unit is C, velocity. Here kilogram power 0, it is equivalent to, don't say that it is equivalent to this I am taking. Kilogram power 0 mass power 1 and second power minus 1. Okay, so this is how I have represented here. Are you following? M1, L1, T1 are the unit of mass, length, time in one system of unit. It is equivalent to here kilogram, what is that, meter, second. And A, B, C are the dimensions, okay, of mass, length and time. So here kilogram power 0, here the same thing, here what is the M1 power A, meter power 1, that is here it is meter, therefore the here unit I have taken as L1, L1 power B, and time second power minus 1, that is given here by T1 power C. Okay, it is just an example, I am comparing it, that's it. Now, therefore what should be U2 therefore second unit, second system? What is U2? Can you tell me? What is
M2A, L2B.
M2A, L2.
comma nahi. No commas here. M2 power kilogram, comma, meter, power. I like that you are representing the unit. No commas here. Okay. So M1 power, M2 power A, L2 power B, T2 power C. Is it clear? Hope you are following.
Yes, ma'am.
Okay.
Yes, ma'am.
Very important,
Yes,
children. Dimensions. Once again, I repeat, dimensions. Dimension of a given physical quantity. Definitely, it won't change with respect to the system of unit that is followed. Dimension won't change, but unit will change definitely. Unit, MKS means kilogram, meter, second. If it is CGS, it is gram, centimeter, second. Are you following? That is the basic concept that is required. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes,
ma'am. Yes, ma'am.
Yeah, what is M1, L1, T1, M2, L2, T2? What are they? They are
Gram, centimeters.
No, you cannot say always gram centimeter. Because I have given I have given an example. It is the unit of mass, length, and time. Okay, with respect to two different systems of unit. Are you following? Let me proceed with this. Okay, right. Therefore, just now we have seen a physical quantity can be represented by N1 U1 that is equal to N2 U2, no? Is it clear? Therefore,
Yes,
just 1 meter per second, that is nothing but 100 centimeter per second. Therefore, physical quantity, how to completely represent a physical quantity, there should be one number and followed by a unit. Okay, if unit is not there, there is no sense in it. And when number is not there, there is no sense. Already, I think I told you these things in the first class itself. Okay, therefore, both are required. Number and therefore that number, N1, U1. This is a number with respect to one quantity, one system of unit. And U1 is the, what is that? A unit with respect to unit of the physical quantity with respect to one system of unit. And N2 is the number with respect to the second system of unit. And U2 is the unit of the physical quantity with respect to second system of unit. Are you following? Okay.
Yes, ma'am.
Therefore, sometimes you may be now only how to see if I am asking you 5 meter per second, that is equal to dash centimeter per second. Okay, so which means that I have N1 U1 here, but N2 you have to find out. Okay, but U2 you have idea which system you are following, you know. Okay, so what you have to find out is N2 is equal to what? Are you following? It is very simple. You know now, 5 meter per second is equal to 500 centimeter. That is very simple, but we are going to solve some difficult problems, different problems, okay, which you cannot give N2 value just like that. You have to calculate. Okay, for that calculation, we'll say dimension is very much useful here. Dimension analysis is very much useful. Okay, right. Therefore, N2 here, the same thing I want here. N2 here is nothing but N1 U1 by U2, correct? Are you following this? Is it clear?
Yes, ma'am.
All of you, whether you have any doubt, you can stop me at any time. Okay. Mokshita, you are following? Dashini, Harshit, are you
Yes,
here?
ma'am.
Harshit, you are here?
Yes, ma'am.
Okay. Harshit, you are following?
Yes, ma'am.
Yes, ma'am.
Now, what am I going to do? N1. Okay. What is U1 here? U1 is this, correct? Okay. I am going to apply that. That is M1 power A. Instead of U1, M1 power A, L1 power B, and T1 power C, correct? Okay. And divided by, if you want, you can even put a bracket if it is comfortable. Okay. Then divided by U2 क्या होता है इसमें? M2 power A, L2 power B, T2 power C. Okay. Okay. Therefore, what is N2? N2 that is equal to N1. Okay. I can give in a proper ways now. That is M1 by M2 power A कर सकते हैं ना? ये L1 by L2 power B. T1 by T2 power C. Correct? Is it clear? Therefore, this is how we have to, by using, this is a very, very handy formula we have derived. Okay. What is the formula? We are, okay, how to convert one system to another system. So here 5 meter per second is equal dash centimeter per second. The dash is N2. N1 U1 is equal to N2 U2. N2, how to find out N2? By using this formula. Hope you are following this. Is it clear? Clear or not?
Yes, ma'am.
Yes, ma'am.
Okay. Therefore, okay. Let us let us first do this one once again by adapting this formula. Okay. What is that? What is the formula? Just very simple.
Yes, ma'am.
Okay. 5 क्या है centimeter per second. That is equal to 5 meter per second. What I have taken here, 5 meter per second. Okay, let it be 5 meter per second. That is equal to dash centimeter per second. Correct? Okay, therefore, which first one you have to see which physical quantity it belongs to. Meter per second. From that you have to decide what is the physical quantity here. What is the physical quantity? Meter per second माने क्या होता?
Less than
What is the physical quantity? Velocity. Physical quantity, meter per second. Okay, or speed, velocity. Therefore, now first step what you have to do. See, it is, you have to see what you immediately on seeing the unit, you should know what is the physical quantity, which physical quantity it belongs to. Therefore, now L that is equal to, sorry, not L, V. V that is equal to, okay, what is that? 5 meter per second. That is equal to dash centimeter per second. That is the question. Correct? Right. Therefore, now next step. Next step. Therefore, what is that? What is the dimension for velocity? See, it is a very simple, just like that you can, but we are adapting. The simplest, what is that problem? I want to apply this formula and see whether you are getting. Okay. Now, what is the dimension of velocity? What is the dimension of velocity, ma? V that is equal to, tell me. What is the dimension?
Power 0, L power 1, T power minus 1.
N0
0, L power 1, T power minus 1. Correct? Okay. Is it clear? Right. Therefore, now can you tell me, I am going to apply this formula to find out what is this value, N2. Okay. Therefore, isme to what is N1 here in the given formula? What is N1? What is N1?
5.
5.
5.
Okay. N2 you have to find out. Correct? And can you tell me what is M1 here?
Meter.
Ma'am, 1 kg.
Mass ma. M means mass.
Meter.
L means length. M,
Ma'am, 1 kg.
M, sorry,
Zero.
M1 is, yes. Why? Because here it is independent of mass na. ये तो क्या है यार? It is 5 m power kilogram. I told you everything. I don't know how I am. See, kilogram power 0. You want me to do like once again? M power 1, s power minus 1. That is equal to minus gram power 0, centimeter power 1, s power minus 1. Are you following? Isme, it is m1, it is m2. I see, it is m1, it is l1, it is t1. It is m2, l2, t2. Hope you are following, children. Be in the class. Okay. What is m1 now?
0.
M1 here actually M1.
0.
At A, that is equal to
kg power 0.
A is equal to 0.
0.
Are you following? And
Yes, ma'am.
what is L1?
M.
Meter. Okay. But what is your B here?
1.
1.
1.
1. What is T1?
Second.
Second.
S. Second.
Yes. What is C?
Minus
Minus
1.
one.
Minus.
Minus 1.
Are you following? Okay. Therefore, what is your M2 here? M2 is gram.
Gram.
Correct? L2 is centimeter. And
Centimeter.
T2 is of course second. Okay. Everything I think you are following now. Is it clear?
Yes, ma'am.
Now you
Ma'am.
substitute. Well, how to substitute? What is N2? That is equal to N2 only you are asked, na? N2 is equal to N1 into formula M1 by M2 power A, correct? And L1 by L2 power B. You write the formula. Once again, I am writing for you, your sake. T1 by T2 power C. Correct? Therefore, that is nothing. But what is your N1?
5.
5. M1 kilogram.
kg.
Kilogram, M2 gram. Power 0. It is not going to matter at all. Correct? Are you following?
Yes,
Are you
ma'am.
following? Right.
Yes, ma'am.
What is meter? What is L2? Centimeter.
Yes,
Power क्या होता है इसमें?
1.
1. T1 second. T2 second. Therefore, what is C?
Minus 1.
Minus 1.
Are you following?
Minus 1.
So it is not going to have any value here because no. Okay, there is no need. Here also both are second by second. One it will become. Are you following? Are you following? What
Yes,
is
ma'am.
left over here?
Yes.
Only length factor only is available. Therefore, N2 is equal to 5. Okay. Meter by centimeter power क्या होता है? 1. Correct? Are you following?
Yes, ma'am.
Nothing. 5. Okay. Now I want only in the second system N2. That is, see what is the denominator? Denominator is centimeter, but your numerator is meter. So numerator, what you have to do? Keep it in the mind. Now see, record it. See, the numerator unit should be converted with respect to denominator unit in terms of. Therefore, meter ka centimeter, what is that? 100 centimeter. Are you following? Divided by centimeter. Power क्या है? 1.
1.
Hope you are following, children. Is it clear? See, numerator unit is there. Now you have to represent with in terms of unit of denominator. Meter. Meter, you know. Meter, what is that? Meter means it is 1 meter is nothing but 100 centimeter. Are you following? Are you following?
ma'am.
Yes, ma'am.
Therefore, centimeter will go. Therefore, that is nothing but 500 aa gaya. Is it clear? Therefore, when
Yes, ma'am.
value
Yes,
is
ma'am.
into value is 500. Therefore, you can give, what is that? 5 meter per second is nothing but 500 centimeter per second. Got it? Got it? Understood?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
This is the method. The simplest I have given, because you know that you can recheck it whether by using your dimension analysis whether you will get it or not. See, I'll just tell you first whatever is you are asked to convert. You see what type of unit is this. Okay, so what is the first physical quantity? What is a physical quantity? First you see the physical quantity, write the dimension. Okay, dimension. Then you have to give what is that? What is M1, L1, T1 in that particular system of unit? Mass, unit of mass, unit of length, unit of time in with respect to one system of unit. And what is with respect to other system of unit? What is the unit for mass, length, and time? Then next one is the dimension, the powers. Okay, so how it depends? That also you first you write all the data. Okay, after that you have to, just like that, you have to apply in the formula. After applying the formula, what you have to do, the numerator, whatever is in the numerator, that has to be converted in terms of denominator unit. Okay, so unit that you do, then automatically you will get the number, that is what is N2. Is it clear, children? Let us
Yes, ma'am.
let us go for
Yes,
some
ma'am.
other problem now. Let us solve some other problem now.
Yes, ma'am.
Yes, ma'am.
Where is see? So the simplest one I told you. Next one. Next you don't know, because we are going from known to unknown. You know 5 meter per second is called 500 centimeter per second. You know, but we have applied, rechecked it. We got it now. I think you are convinced now. Okay. Now let us go to the unknown. You are asked to find, convert the problem now. Convert. Definitely you don't know this. 1 Newton, okay, into dyne. Convert, this is the problem. Convert 1 Newton into dyne. This is the problem. Newton is one system, dyne is the other system. Okay, therefore, what is Newton? Newton means in MKS system. Dyne, what is the physical quantity involved here? That you tell me.
Ma'am, force.
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 That you have to, on seeing the unit, you should have an idea what is the physical quantity involved. Okay, therefore first step what you have to do, force. Okay, that is nothing but 1 Newton, correct? That is equal to how much dyne? That is the question, correct? This is our question. Therefore, what is next step? What is the dimension of force? Same method you follow. Okay, same steps. Dimension of force. Yep. That is equal to m power 1. Tell me.
M1.
M1.
L power 1.
T power minus 2.
minus 2.
That's it. T power minus 2. Are you following? Right. Now tell me, what is the dimension? What is A value? Let me see. What is A?
1.
1.
B?
1.
1.
Minus 2.
That is
Minus 2.
From that you can give ABC values, correct? Right.
Yes,
Now
ma'am.
you tell me 1 Newton. It is MKS. You are asked to convert from MKS to CGS actually. Okay. Or SI system also. You can. Okay. 1 Newton means M into A na. F is equal to M into A. When F will be 1 Newton, M is equal to kilogram. Okay. A is meter per second square. 1 Newton means what is that? It is F is equal to m into a na. M क्या unit क्या है? Kilogram. Acceleration का unit MK system में क्या है? Meter per second square. Hope you are following this. 1 Newton is nothing but, okay, you cannot apply 1 Newton as such. You have to convert it into how many dimensions of mass, how many dimensions of length, and how many dimensions of time. Okay, for that, what is 1 Newton? 1 Newton is equivalent to 1 kilogram meter per second squared. So I have given Newton in terms of kilogram, meter, and second. Fundamental units. I hope you are following. Okay.
Yes, ma'am.
Yes, ma'am.
Dyne. What is 1 dyne? 1 dyne is equal to 1. Tell me now.
Gram centimeter per second square.
That's it. Are you following? With this, can you give me what is M1?
Kg.
M1
Kilogram.
Kilogram.
kg,
Kilogram means 1 kilogram. Kilogram means 1 kilogram, right? And there is no need to write. L1 is
1 meter.
meter,
1
and
meter.
T1 1 second. And what is M2?
1 gram.
Even just also that is correct. I'm not okay. L2 that is equal to 1 centimeter and T2 that is equal to 1 second. Hope everything is fine now. Okay. And what is your N1?
1.
1. Convert 1 Newton into dyne. Correct? Right. What is N2? You have to find out. Is it clear, children? Whether you have understood the problem. This is the problem first. Okay. Only you have to
Yes,
go for
ma'am.
solve. Therefore,
Yes, ma'am.
how to solve? N2 that is equal to formula. Always you write the formula. N1 into, after that you can substitute. M1 by M2 power A, L1 by L2 power. If you write so many times, then it will be recorded. B, T1 by T2 power C. This is the formula required. Now you substitute. Okay, let me go for some other color. N2 that is equal to what is N1 is 1 only now. Okay. Therefore, what is? I'm waiting. M1 by N2.
1 kg by 1 gram.
Power
1 kg by 1.
1.
1.
1. Okay. Then 1 meter divided by 1 centimeter power
1 centimeter.
power
1.
1. Okay. Then 1 second by 1 second power
Minus 2.
Minus 2.
minus 2.
2. Okay, that it is not going to matter here, correct? Second it will go. Therefore, N2 that is equal to 1. अब क्या करना है अभी? Numerator को you have to give with respect to denominator. Okay, 1 kilogram. Convert it into gram. 1000. Correct?
1000.
1000 gram divided by 1 gram. Power क्या होता है? 1. Right? Next. Meter.
100 centimeter.
100 centimeter divided by centimeter. 1 centimeter power
1.
1.
Okay. Gram goes, centimeter goes. Therefore, what is N2 is equal to 1 into 1000 into 100. Correct?
Yes,
10 to
ma'am.
the power 5.
Equal to 10 power 3 into 10 squared. That is N2 that is equal to 10 power 5 are right now?
5. Yes.
Okay, 10 power 5. Oh, therefore, 1 Newton that is equal to how many dynes?
10
10
power
to the
5.
power 5.
10 power 5.
Are you following? Clear?
Yes,
Under-
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
one more problem you want?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Shall we go for convert? Next problem. Convert. Okay. An energy of 1 joule, 2 joule, 1 joule to 1 erg, E-R-G. Just creating problem. Yeah, E-R-G, erg. Joule to erg. Okay, what is a joule? Unit, SI unit of energy, because it is given energy. Okay, SI unit of energy is joule. Like that, erg is CGS unit of energy. Are you following? Is it clear? CGS unit of energy is given by erg. Okay, therefore, first step, how to find energy? Energy usually is denoted by U. The proper way of energy, how to represent U. E means electric field. Then U. Energy that is equal to, what is that? 1 joule. That is equal to 1 joule is equal
1 kilogram.
erg. What 1 kilogram?
1 joule is equal to.
Now wait. Whether it is clear? Clear? If you have any energy. Okay.
Yes, ma'am.
Energy. Okay. Therefore, next step, what is that? What is the dimension of energy? Dimensional formula.
M1 L power 2
Dimension
power minus 2.
of energy, that is M power 1,
1
L power
L power 2
2
L square, T
T
power.
power minus
minus 2.
Minus 2.
minus 2.
Yesterday we have seen, no? M L square T power minus 2. Second step is over, right? Now what is that? We have to give. What is A?
1
1
1,
B?
2
2
2,
minus 2.
Minus 2.
Okay, this step is over. Right. Now, 1 joule I have to give represent with respect to fundamental systems. Na? So, 1 joule, that is equal to, okay, 1, tell me, kilogram
Meter square
square per second square.
per second minus 2.
Okay, correct. Like that, what should be 1 erg? 1
Gram centimeter square.
equal to 1 gram centimeter squared per second. Hope you're following this. Okay, because a joule, immediately you have to convert that with respect to fundamental base units. Okay, right. Now you tell me what is M1. M1 is kilogram. Okay, L1 is 1 meter. T1 that is equal to 1 second. Is it clear? After that, we will go to some complicated unit also. Okay, you should know. Any system of unit to any system may not be available practically. It is not available, but they may ask you. Okay, some different units converted to this unit like that. That problem also you have to do. Okay, we are going from known to unknown. That is why I am using very simple one. What is M2?
Gram.
Gram.
Gram. L2, 1 centimeter. T2, 1 second. Okay. Right, now you substitute in the formula. N2 that is equal to N1 into M1 by M2 power A. Tell me. By the time you complete. Okay, no problem. So, what is your N2 therefore? Now you tell me what is N2.
Ma'am,
Yeah.
Ma'am,
it
L1
should
and 2.
be L1, L2.
L1. Good. Okay, right. Therefore, what is your N2? n2 that is equal to, इसमें n1 क्या होता है? n1 is equal to 1 मान लेना. 1. n2 that is equal to what? Right. Therefore, n2 that is equal to, tell me now, n2 is equal to what is n1? n1 is
1.
1 kilogram divided by 1 gram power 1.
One.
1 na? Right. Then 1 meter divided by 1 centimeter power
2.
2.
1 second by 1 second power
-2.
-2.
-2. Okay, therefore that will go. Therefore, what is
Ma'am,
left?
answer is 10 to the power 7.
n2 that is equal, yes, 1 kilogram. Kilogram is 10 power 3 grams enough, divided by 1 gram. Power 1. Then centimeter, meter, 100
10 to
centimeter.
power 2.
Therefore, 10 squared, 1 centimeter, power 2. Gram, centimeter goes. Therefore, now what is your n2? That is equal to 1 into 10 power 3 into 10 power?
10 power
4, ma'am. 10 power.
4.
Okay, therefore n2 that is equal to 10 power
7.
Correct?
7.
Therefore, you got the answer now. Therefore, 1 joule that is equal to how many eggs?
10 to the
10
power
10
power
power
7.
7.
Are you following? Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now we will go for some different units, star units, something like, which is actually not there in physics. But just to, you should know how to convert. It is a hypothetical unit, which is not there. Okay, that they may ask you to convert this unit to that unit like that also. It's very, okay, so how to deal with that, we will see tomorrow.